All right, let's get going on chapter 13. Chapter 13 is called Solutions. It's a little bit different from what you already covered in chapter 8. It focuses on solution properties, so-called colligative properties. How what is dissolved in a solution affects boiling point and freezing point and things like that. And there'll be mainly calculations that I will cover in this lecture. Chapter 8 was more about concentration, the solubility rules, and a little bit of redox chemistry. All right, so this is called problem solving. All right, so I will cover less background and conceptual stuff in here. I will focus on those problems that you might appear on an exam for you. So they'll be more condensed, and I'm planning on doing this from here on out for all of the remaining chapters for General Chemistry 2. And if you do need any background, you can read the OpenStax book, or you can ask me and I can point you towards some other YouTube videos or direct readings. All right, so as a review, it's important how we express concentration. All right, now how much stuff is dissolved in your solvent, right? And so aqueous solution, just as a reminder, means that we have water as a solvent, and then what's dissolved is the solute, okay, the stuff in it. And we know from previous chapters why some things dissolve and others do not. So a solution is basically any homogeneous mixture. All right, and that can even be a solid, can be considered a solution as long as there are two components, a solvent and a solute. But it's important to remind you that the main way chemists express concentration is by molarity, you know, not mass percent, like how many grams are dissolved in 100 milliliters, which is what this is. That's also important. And so this would be the units would be here in grams per milliliter or per gram of solution, depending on the type of mass percent. Like if you can have mass, right? So grams of solute divided by grams of solvent, or volume, milliliters and milliliters, but it's basically grams per 100 units. That's percent, 1 part in 100 anyway. Molarity is really the most common way that the chemists express solutions. So that's the number of moles per liter of solution, and it has a total of a liter. So if you want to make a 1 molar solution, you have to take 1 mole of something and add just enough water to get to exactly 1 liter. So that would be molarity. Now that's abbreviated with a capital M. We also have something, and this is new, called molality, and that becomes important for these calculations we're going to be doing today. That's a small m. It's a little different. It's very similar to molarity, but it is the moles of solute per kilogram of solvent. And this is just solvent plus solute. So not solute and then you add enough to make a kilogram of solvent. No, this is when you separately have, let's say, 1 mole and you add 1 kilogram of solvent to that. Okay, so this is going to have a lower molarity than if you took 1 mole and you added enough solvent to make a liter, right? So a kilogram, if you had a kilogram of water, it would be a liter. So that's why it's very similar. So you're adding here, right? So if you have 100 grams of sugar and you add a kilogram of water to that, then that results in probably 1.15 liters or something like that. But that would be if you convert the grams of that sugar to moles, then you could calculate the molarity, pretty easy. So pay attention to little m and capital M, and then it's also important the number of particles. And then we'll get to that a little later, right? But you do know that a polar covalent compound such as sugar doesn't break into particles when it's dissolved. It just interacts with the hydroxyl groups to dissolve in water. So you have 1 particle per molecule. But if you have something like sodium chloride, for example, this will break into 2 particles, sodium and chloride. And what did I say? No conceptual stuff. I've done nothing but conceptual stuff in the first 4 minutes, so I promise that will change. Alright, so let's jump right in and do a review calculation here, right? So if we have sodium chloride and water, and we're giving 112 grams of sodium chloride in 1 milliliter of solution, 1 liter of solution, find M and mass percent. So M is molarity, and then they also give you the density. So we'll see what we need that for, right? So if we want to do molarity, we need the number of moles of solute per liter of solution. And I am given exactly 1.00 liters. 1.00 liters of solution. We need to just know the number of moles of sodium chloride then, right? And so that's why the units are so important, that you don't just say, oh, here's my solute, I'll just slap 112 grams on top of that and get it. No. It's supposed to be moles per liter, so you can't put grams there. So you have to convert grams to moles. And if you remember 101 grams, you can convert that with the molar mass. So you go to the periodic table. Hopefully you remember how to get the molar mass of sodium chloride, but it is 58. 1 mole of sodium chloride is equal to 58.44 grams of sodium chloride. Okay, so that's the conversion factor. So I do times 1 mole divided by 58.44 grams, and it gets a little crowded here. I'm not planning that out very well, but that's 1.92 moles. We have 3 significant figures here, 3 significant figures there. That goes up here, so that's 1.92 moles. And so the answer for molarity of this solution would be 1.92 capital M. That is the molarity. So we just did this. All right. So that solution, because we have some solute in there, is no longer going to have a density that's 1.00. So it's slightly different. It's not going to make a big effect. But if we do have a liter, what we want to know for mass percent is we want to know the grams per. So if we do mass percent, so 112 grams, we want to know how many grams of solution we have, right? So it's not 1,000 grams. If we have 1, we got to convert this, right? Because the units of density are grams per milliliter. So we need to convert liters to milliliters. So we have 1,000 milliliters. And if we apply that to the density, we can get to grams, right? So there's 1.08 grams per milliliter, right? Because we have a liter and we're given the density. And so this gives us 1,080 grams of solution. And that's what mass percent is. So now we divide it by 1,080 grams times 100 to get a percent, and so we end up with 10.4%. Alright, so that's the percent. Alright, so here I have everything worked out, so you can look at it. The slides are posted, of course, and in case I was a little chaotic here, but I worked through the problem so you know how it's done, and here it is all written out. Let's work another problem. It's also a review problem. Basically, this is something you should know how to do. Silver nitrate solution are used to plate silver onto other metals. What is the maximum amount of silver in grams that can be plated out of 4.8 liters of solution containing 3.4% silver by mass? Assume a density of 1.01 grams per milliliter. Okay, so we want to know how much silver, not silver nitrate, just silver, is there in 4.8 liters. So we're given 4.8 liters, and we're told it's a 3.4% solution silver by mass. All right, so we have 4,800 milliliters. So in order to get to grams, I'm going to apply this density here, and it's not going to make a big deal, but we need to get from milliliters to grams so that we can apply the percent and get grams of silver. So times 1, and because we just have two significant figures, it probably won't matter at all, but let's do this anyway. 1.01 grams per milliliter is then going to give me 4,848 grams, which two significant figures would be 4,800. But let's just keep it going. Our final answer has to have 3 significant figures, right? And so I now take that 4,848 grams and apply the percent to it, right? So times 0.034%, and that's going to give me 164.8 grams of silver. All right, so this would then be 160 grams of silver. That's the answer already. So this long, wordy problem turned into a pretty simple problem. If you have a percent, you can actually use that as a conversion factor. I want to show you that. So you can work this a little differently. Rather than applying the percent, you can actually play the unit game the way I've shown you over and over, factor dimensional analysis, right? Because what this means is that there are 3.4 grams of silver in 100 grams of solution, so equal to 100 grams of solution. This is then a conversion factor, so you can say that there are 4,848 grams of solution. You use the conversion factor, you divide by 100 grams of solution, and you multiply by 3.4 grams of silver, and then that also gives you 164.8 grams, or two significant figures here, 4.8, that's all we got, 160 grams of solution. All right, let's keep these short, move on to the next one if you have time, but that's it for lecture number 1.